Hi everyone, this is Shangbang from Google Research. I would like to introduce our paper, Hierarchical Text Spotter for Joint Text Spotting and Layout Analysis. It's a follow-up work to our previous paper at CVPR 2022 towards end-to-end unified syntax detection and layout analysis. In this paper, we propose a dataset and a new model for joint text detection and layout analysis. You can scan the QR code to access this paper. This previous work, however, has the following shortcomings. First, the text line detection is represented as mask, which is not as convenient as a polygon when it comes to curved text line. If we detect text as mask, we then need extra post-processing, for example, a rectification module in the text recognition model. Secondly, this model only detects text line and paragraphs. It doesn't detect character or word levels. Finally, there's no recognition module. In this work, we present Hierarchical Text Spotter. It takes an image as an input. It outputs a four-level text hierarchy, from character to word to line to paragraphs. Hierarchical Text Spotter mainly has two stages. In the first stage is the Unified-Detector-Polygon, which is an improved version of the unified detector in the previous work. It detects text line with bounding polygons and an affinity matrix for paragraph grouping. In the second stage, we have a line to character to word recognition model, where the inputs are text lines. The output are bounding boxes of each characters and also the clauses. Note that this recognizer also outputs spaces, which we use to decompose text line into words. We designed a unified detector polygons based on the original unified detector. We simply add a new prediction head to predict Bezier curve polygons. Specifically, each text line is modeled as a pair of Bezier curves, one for the top edge and one for the bottom edge. Unlike previous work that directly predict Bezier curve control points, we added a new location and shape decoupling module. It has two prediction heads. One head will predict the axis line bounding box for the text line, and the other head predicts the normalized coordinates of the Bezier curve control points. Later in the ablation studies, we show that this module is very important if you want to train a unified detector polygon on a large diverse dataset containing a large variety of aspect ratio text with only a small amount of curved text, without fine-tuning on curved text datasets specifically. Next is the line to character to word recognizer, where the inputs are cropped text lines. The recognizer is a transformer encoder decoder based model. Its architecture is also very simple. It contains a mobile net to extract features, and then there's a transformer encoder and transformer decoder that recognizes the text in an autoregressive way. The transformer decoder, however, has two different prediction heads. One is for the character class, and the other is for the symbol box. Note that the symbol box part is only trained with partially labeled data, which essentially is synthetic data. We found that training the symbol head with only synthetic data is efficient enough for the model to also predict symbol boxes on real image data. Note that the vocabulary of our model includes a space character. In the post-processing, we use a space character to divide a text line into words. The next section is demo. Feel free to pause the video for a closer look. In each example, we show the grouping of different levels.
From character to words to line to paragraphs. The
Next, we would like to show some quantitative results compared with previous works. In the first experiment, we compare with previous works on the ICTA 15 evaluation benchmark. All the results are evaluated using the evaluation protocol of ICTA 15, which ignores case sensitivities, punctuations, etc. Our models achieved higher accuracy than all the previous methods. And notably, even when without any vocabulary list, our model are still more accurate than most of the previous methods using vocabularies. For fairer comparison, we retrain some models using the same set of data, including high text, ICTA 15, and total text, and evaluate using the same high text evaluation protocol, which are more strict. We also compare the new method with the old unified detector on layout analysis results. In the ablation studies, we study the effectiveness of the location and shape decomposition module and the design choice of using polygon instead of mask-based detection, and also using a line-based detection instead of word-based detection. Thank you. You can scan this QR code to access the archived version of this paper for more details.